All right, there's the lesson. This is Unit 2, Lesson 3, Probability with Dice and Cards. We are going to use the PowerPoint that is on Canvas. And if you will, please hit the next slide there, ma'am. And that slide says, using one six-sided die, what are all the possible numbers that you can roll? Write your answer on your lab sheet. So we handed out the lab sheet, or it's on the canvas if you're at home. If we have one die, how many possible numbers can you roll with one die? Like this one, right? There's 6, isn't there? You can roll a 1, you can roll a 2, you can roll a 3, 4, 5, or 6. So, what are the odds of rolling a 2? 1 out of 6, right? And if you run that through, you divide 1 by 6, it will give you this decimal. And to get to percent, because Americans do not like decimals, we just don't. You multiply that by 100, you're going to get about 17%. Does that make sense? So about 17% of the time when you roll a dice, one die, it will come up with these numbers. These are equally distributed, meaning each number has the same possibility of being rolled. Okay? Easy enough? Nothing special there, is there? Okay. Next slide, ma'am. Our next slide says, using two six-sided dice, what are all the possible combinations you can roll? List the combinations and what they add up to. The sum of, and this E is a fancy E, it's Greek. Okay, it's uppercase sigma, but you put that on your lab worksheet, and here's your example. 1 and 1 is going to be 2, 2 and 1 is going to be 3, and I started filling the grid out on your sheet, but this is the grid. If I have 2 dice, 1 and a 1, that's going to look like this, and when I add those up, that equals the 2. I'm going to take this second die and I'm going to turn it to where it's 2. So this one stays at 1. And I do all the possibilities with the second dice, with the first dice staying in the 1 position. So I have 1, 1, 1, 2, 1, 3, 4, 5, and 6. When you add them up, that adds to 2, 3, 4, 5, 6, and 7. Does that make sense? And you can fill your grid out because you need to do that on your lab sheet. And you at home can do that also. I then take the dice and I turn it to a 2, the first one, and then I go through this whole pattern again. Okay? This one equals a 3, 2 plus the 1 is 3, 2 and 2 is 4, and we go on down and we get a possibility of 8 with 2 and a 6. Turn the dice over, and with a 3, all these are in 3s, and then this dice changes. And I get 4, 5, 6, 7, 8, 9. I turn the dice again to 4s. These numbers. 5s and 6s. So I fill this whole grid out. Now, the shape of this grid, mine's not to scale, but it forms a square. There are 6 possibilities down. There are 6 across. So we've listed all the possibilities. Next slide. What are the odds of rolling each possible number using 2 six-sided dice? Use a number line and fractions for each possible number. How many possible combinations are there with 2 dice? I can wait. I'll wait you out. 36. How did you get your answer, sir? And that's right. Very good. Because you're going to do well. You're a grad school candidate. That's right. There's 36 total possibilities because it's written on the board. 6 times 6 is 36, if you'll notice. That is 6 to the second power, isn't it? Or 6 squared. This forms a square. With one die, there are 6 possibilities. There are 6 sides on the dice. That's your variable. And there is 1 die. That's the unit. So variable, and then the unit is the exponent. 6 to the second is 36. What if I had 3 dice? How many possibilities would there be with 3 dice? It'd be 6 to the third, wouldn't it? So you'd go 6 times 6 times 6. So you wouldn't just have 2 of these, you'd actually have 6 of these grids. And that's what happens when you cube a number. If this were a number line, you'd have this many in there, and then you'd have 6 of them, and then you'd have 6 deep. So it goes into 3D. And that's the basis of 3D printing. Okay, so we're going to put all these on this number line. So what we do is, on the bottom down here, we start a number line and we go out to 13. And this is, I need to write that down there. These are the odds of rolling each number with 2 dice. Okay? And I'll draw a line here because this is different. Yeah, you can move up if you need to. You sure can. All right. Now, on the upside, and do you know what axis this is if you're doing the axes? Which one is this? X, and then this one's Y. You've heard of an XY axis? That's what we're doing. This is just a simple grid, okay, or simple chart. So on this one, we're listing the number of possible combinations, which means, is there any way to roll a 1 with 2 6-sided die when you add them up? Is that possible? It is not, is it? Because the smallest number you can get is 2 1s, which is snake eyes, and that's a 2. How many ways are there to roll a 2 with 2 6-sided dice? 1. It's right there. So I come out to the grid, and to roll a 2, there's 1 way to do it. So the fraction, it's asking on the roll sheet or the lab sheet, how many ways are there? There's 1 out of how many? 1 out of these 36. So that's what this fraction's here for. Now, if I want to roll a 3, how many ways can I roll a 3? There's a way, and there's a way. So there's 1 way to do a 2. There's 2 ways to roll a 3. I come out here and graph it at 2, and then underneath I put 2 out of 36 under 3, because there's 2 ways to do it. With 4, I've got 3 ways. You see these diagonals start to cut through this square? Okay? And it starts to climb, doesn't it? There's 3 ways to roll a 4, 4 ways to roll a 5, 5 ways to roll a 6, and 6 ways to roll a 7. Notice that the 7 is the corners of the grid. So if I count through or draw this line from one corner to another, that's the longest line I can draw, and that's the number that will be rolled most time in simple probability. There's 6 different ways to roll a 7. Now when I go to 8, instead of it continuing to climb, it starts to go back down. See how these go up? And now at 7 it peaks, and now at 8 I start to go back down. And it goes back down to a 1. So if I took this point right here, that would be the midpoint. I could fold this over and these dots would touch if I folded it in half. Okay? Now, if I add all these fractions up, what do you think I'll get? Follow the grad school student. It's written on the board, right? All of the fractions, and when you see this fancy E, that means add them all up or sum of. It's Greek. It's going to add up to 36 out of 36. 36, anytime you have one number over another in a fraction, what does that equal? 1, or a whole, or 100%. That way you know you have all the possible numbers that you have possible. Okay. So you need to list that on your lab sheet. You need to do this right here and put that on your lab sheet. Next slide, ma'am. You're just doing good. What is the sum of all possible combinations using 6-sided dice? Right there. 36 of 36 or 1. So that's what we talked about. Okay? Next slide. What number is most likely to be rolled using one 6-sided die? Is there one number up here using one that's more likely than another? No, there's not, is there? So the answer is none. That's the answer. Next slide. What number is most likely to be rolled using two 6-sided die? Can you use this information and tell me? 7. How'd you get your answer? Because it's on the board. Where on the board? Right here? Okay. That's correct. There's 6 different ways to roll a 7, so that number's most likely to be rolled. Is it written somewhere else too? No? Just there? Okay. Next slide. What's required for data to be normally distributed? This is a normal distribution. This is not. This is a flat. If you do it with the 1 die, you would have 1 through 6, and each one of them would have 1, and your dots would just be here at the 1. I probably need to go ahead and do that. Fact is, I will. So let's draw this line on out here. And then we have 1, 2, 3, and we'll just put possibilities out here. And then this is your number. 1, 2, 3, 4, 5, 6. Okay, and there's one possibility at each one. So this one just forms a straight horizontal line. See how this starts forming a curve? If you connect all those dots together up there, you're going to form a curve. We're going to learn about that hot and heavy, maybe not tomorrow, but maybe for sure the day after. Next slide. Is rolling one 6-sided die normally distributed? Yes or no? Yes. Yes? How'd you get your answer? You guessed, and that's okay. Sometimes guessing works. Sometimes it doesn't. In this case, it didn't work. If it shows a flat line on top, that's not a normal distribution because some things are more likely to happen than others in a normal distribution.
Why do you write in all capitals?
Because I do. So it's a disability that I have, but I can write very fast that way.
What does it say?
It says some things are more likely to happen than others in a normal distribution. So rolling one 6-sided die is not normally distributed because everything has the same chance of happening. Next slide. Is rolling two 6-sided dice normally distributed? Yes, look, there's more chance to roll numbers that are in the center than there are out in the ends of the scale. That's a normal distribution. Okay? Science jumped all over this. Statistics and math jumped all over this. They developed it. This can be used to determine who the next president will be, and it is so accurate that they will not start publishing results of an election until the polls close on both coasts because they were doing polls and starting to get returns in the old days, and they were publicizing them or putting them on the news, and people on the West Coast go, well, my candidate doesn't have a chance, I'm just not even going to go vote. So they said, nope, we're not going to do that. We're not going to start publishing them until the West Coast closes. What time do the polls usually close? Do you know? Isn't it 7? So if it's 7 in Los Angeles, what time is it in New York? You got Mountain Time, Central Time, and Eastern Time. Big difference, isn't there? Yeah, so if you're in New York, the returns don't start coming in until late night. So if you want to know who wins first, you have to sit up all night. Okay. So is rolling 2 dice normally distributed? Yes. Next slide. Roll 1 6-sided die 20 times and record your results. That's what you're going to do after I get finished yakking at you up here. Okay? That's your lab. So you'll do that, put the results on that sheet. Next slide. And then you're going to roll 2 6-sided die and record your results. I have dice and I'll give them to you. We'll use the box tops again because that helps and we don't chase dice across the floor. Next one. Add all 20 rolls of the one side together and divide by 20. That is the mean. The mean is the average. This is the symbol for mean. I will refer to that as X bar sometimes because sometimes we do that. So X bar, or the mean, is the average. And to get the average, you add all your numbers up and divide by how many numbers there are. Okay? No big tricks yet. This is all middle school math. Next slide. Add all of the 2 sides together and do the same thing. So you're going to do it for your 1 die, you're going to do it for your 2, and you're going to find the average number, the number you rolled most often. Next one. Using a deck of normal playing cards with no jokers. I just happen to have that right here. Put that up, yeah. Come on. There it is. Using a deck of normal playing cards, no jokers, lay them out in a grid pattern by suit, starting each suit with the king. We did that. Followed by the queen. There's the queen. And so on down to the ace. We count the ace as a 1. A lot of people, that's the most valuable card in the suit, but we put it down here because it's also referred to as a 1. Complete the grid on the lab worksheet. Your lab worksheet has the grid started. This is the entire grid. So what I did is I took clubs first. Clubs is a black set of cards. We start at king, queen, jack, and then the number cards down, and then the ace is the last one. We did the same thing with the hearts. Put them all together. Spades and diamonds, that's the 4 suits in a regular deck of cards. How many cards are in a deck of cards? No jokers. 52, right? There's 13 in each one of these suits, and there's 4 suits, so 52 cards, 13 times 4. Next slide. What are the odds of drawing a heart? All these cards are a heart. This is the heart, this is the whole suit. Okay, how many are there? 13. How many total cards? How many total cards? 52, that a babe. All right, so 13 divided by 52 equals 0.25 on your calculator. And I would highly suggest a Texas Instrument Big Tex calculator that you can get for $8 at any of your local Target stores. I don't know that they have them at Walmart anymore. They used to, but they're not now. Okay, To change a decimal into a percent, how do you do that? Multiply it by 100, which moves it 2 places, 25%, and then this number will reduce. 13 will actually go into 52 4 times. That's where this 1/4 comes from. Okay? Makes sense because there's 4 suits, they're identical, and your odds of drawing one of these cards is 1 out of the 4. What are the odds of drawing a queen? You have how many queens in a deck of cards? 4. Out of how many cards? 52. So 4 out of 52 equals 0.077. You multiply that by 100, you get 7.7%. And it's 1 out of 13, and that makes sense because each one of them, the sets of 13, there's only one of the cards that's a queen. That's 1 out of 13. That's where it comes from. What are the odds of drawing a queen or a heart? I missed on there. I got to fix that up on the PowerPoint. A queen or a heart? Well, what are the odds of drawing a queen? 4 out of 52. What are the odds of drawing a heart? 13 out of 52. So if I add those together, now when you add fractions, you have to have a common denominator, don't you? Yeah. So 4 out of 52 and 13, 4 and 13, 17. There's 17 different ways that can happen out of 52. We're going to count this card twice. Don't get into mutual exclusion and all that yet. We'll worry about that when you move on. Or you take stats full time. If you like this kind of stuff, stats is a good course for you. And statistics are very powerful. If you learn how to use them, you can find a job. All right, this card is counted twice in simple probability because it is a queen and it is a heart. We'll worry about the other later. All right, this is, if it has or in the question, you add the fractions together. See or right here? If it says a queen or a heart, you add them. What are the odds of drawing a queen and a heart? The card has to be a queen and a heart at the same time. That is this card. Are there any other cards in that deck that are a queen and a heart? Yes or no? If it's yes, show me where it is. I can't find it. It's right here. There's 1. So the odds of drawing a queen are 4 in 52, right? Same as it was up here. The odds of drawing a heart are 13 in 52. If I multiply those two fractions together, do I need a common denominator? No, I do not. So I multiply 52 and 52 and I get this number, 2704. I multiply 4 and 13, I get 52, which makes sense because there are 4 sets of 13, 4 suits, 13 cards per, it's 52. If I divide this whole fraction, I reduce it by 52, I get 1 out of 52. That makes sense because there's only one card right here. So, for the and/or principle of probability, if and is in the question, you multiply. And if or, you multiply. If or is in the question, you add. If and is in there, you multiply. And that's the and or principle of probability. Next slide, ma'am. What are the odds of drawing a black card? How many of these cards are black out of the 52? All the clubs and all the spades, so that'd be, 26, wouldn't it? So half of them, 50%. What are the odds of drawing a red card? Be the same, wouldn't it? Yeah. Okay. What are the odds of drawing a face card? Now, a face card is the one that has people's faces on it, the kings, the queens, and the jacks. We don't consider, or I don't consider, an ace a face card because it doesn't have a face on it. So how many face cards are there in a deck of cards? There's 12. That's right. So 12 out of 52. And if you wanted to find the percent on that, how would you do it? 12 divided by 52. Very good. You guys your math teachers did a good job with you. All right. What are the odds of drawing a red face card? So, of these 12, only 6 of them are red, right? 3 here and 3 here. Okay, so it's 6 out of 52. How many diamonds are in a deck of cards? How many diamonds? 13. That's right. How many spades are in a deck of cards? Same trick, right? 13. What are the odds of drawing a face card? We just talked about it. What is it? 12, that's right. 12 out of the 52. Next slide, ma'am. Look at her go. The and/or principle of probability, that's right here. That means that if or is in the question, you add them. If and is in there, you multiply. You might want to put that on your worksheet. Okay, we are now going to distribute the dice, and we can distribute the cards, but primarily the dice, and we will do the lab. And you guys at home, we will see you when you get here. If you have some dice, you can do this one. If not, we'll try to figure something out. But anyway, that's it.